So assignment moment. First is question number 3, the doubts related to the question. That is, the first one is question number 3. A thin wire which is having a negligible mass, so the mass of this wire is negligible, is used to hang a picture on a wall. The wire is hung over a nail and can be attached to a picture using arrangement 1 or arrangement 2. So two different arrangements are there, as you can see. Deduce which wire arrangement would be used to keep the tension in the wire as small as possible. So we have two different arrangement. Arrangement 1 is there and arrangement 2. So how we can work out, basically, see the tension. So this will be the tension T. This will be the tension T. And both cases, the picture is of same weight, which is acting downward. So weight is acting downward, weight is acting downward. And here also tension T will be there, the tension T. Now, when we will resolve this into component, the angle with the vertical, if we say the angle with the vertical is theta for each of the tension, here we have T, this one is also T, the weight is acting downward. This one is T, this one is T, and the weight is acting downward. So this is an angle theta here. So with reference to the angle, the component of the force which is with an angle, that is cosine theta. So this will be T cosine theta. And against this will be T cosine theta, and the other one will be T sine theta. So this will be T sine theta, this is T cosine theta. So T cosine theta is acting up, and for the other on the right hand side also T cosine theta is acting up. So the total upward component of the tension, that is T cos theta and T cos theta, and the downward force is a weight which is acting down. So as a result, because it is stationary or equilibrium, so we can say that 2T cosine theta, so 2T cosine theta or 2T cos theta is equals to weight. So weight is constant, it means the product of T and cos theta, the product of T and cos theta will decide the value of the product should be constant because the weight is constant here. So, and what is the relation between theta and cosine theta or theta and sine theta? So theta and sine theta are directly proportional to each other. If the theta increase, the value of the sine theta will increase as well. Where theta and cosine theta, because cos 0 is maximum and cos 90 is 0. So as a result, what will happen? If the value of the angle increases, the value of the cosine theta will decrease. So the question is, when we compare the angles, as you can see here in arrangement 1, the angle is smaller, but in arrangement 2, the angle is larger, the theta is larger. So if we are talking about arrangement 1, the theta is small. If theta is small, what will happen to the value of the cosine theta? The value of the cos theta or cosine theta will be large. If the value of the cosine theta is large, and we know the product of T cos theta will be equal to W. So if cos theta is large, then the T should be small. So it means in arrangement 1, where the angle is small, the value of the cosine theta or cos theta will be large. As a result, T will be smaller. But for arrangement 2, when we check for arrangement 2, what will happen? The theta is large or big for arrangement 2. So if the theta is large or big, so when the value of the theta is greater, what will happen to the value of the cos theta or cosine theta? That will be small. And 2T cos theta is equals to W. So the value of the cos theta is small, the value of the T should be large. So means that here the tension in arrangement 2, the tension must be larger, where in arrangement 1, the tension should be smaller. Is it clear, this one?
Yes, clear.
So this was question 3 part A. So when you write in exam, first thing you will mention that weight is equals to 2T cos theta. So whenever object is hung by using a wire or a string, in that case, the weight is balanced with a cosine component of the tension. So because two strings, like two parts are there, that's why it is equal to 2t cos theta. And the value of the theta increases. If the value of the theta increase, the value of the cosine theta decrease. So in arrangement 1, we have a smaller theta. That's why the value of the cosine theta is larger or bigger, and the product of t cos theta should be equal to W or the constant. So if the value of cosine theta is larger, the value of the T is smaller. So this will result in a smaller tension. Then the next one is question 5 part B. In this question, a book of length L, which is having a weight W, is positioned on the shelf, as you can see. What is meant by the center of the gravity? So how we define the term center of the gravity, which is a point where the weight of an object act, that is known as the center of the gravity. Then there are contact forces at two positions, and where the book touches the shelf, the book is moved at a distance x. So we move the distance x to the right as shown. The magnitude of the contact force vary with x, because the total downward force will change as a because it's like the clockwise moment must equal to anti-clockwise moment. So the magnitude of the contact force R vary with x. Sketch on the axis below the variation of a R with x between 0 to L by 2, and you should include uh, mark the maximum value of R on the two axes. So how we will carry out this? First, the total length is L, and the idea is that we are moving the full book to a position here until we move to a distance L, like it will be here. So weight is acting downward. Here also weight is acting downward. So the idea is that the clockwise moment must equal to anti-clockwise moment if it is in equilibrium. So when you're checking the first part, because at this position, when L is 0, then quarter, then L by 2. Like from this position, the starting position, till we move to a distance L by 2. And X is a movement, like the variation is there. So the total clockwise and anti-clockwise moment should be equal to each other. Now, this one is R, and this one is W. So when we did not move, like approximately, as you can see, the approximate distance is there from the point. This is example a point of rotation or a pivot. So the total clockwise moment must equal to total anti-clockwise moment. Now, when we compare the distance example, if we consider that like we did not move the book, so this distance, the weight is acting at the center, the combined center of the gravity for the book as well as the beam. So example, the combined center of the gravity that is acting here. So at the center, and R is exactly the full length. So if I say, if this was 2 meter, if I use a value, without value, I can also say, and this one is 4 meter. As the clockwise and anti-clockwise moments are equal, this is causing an anti-clockwise, weight is causing a clockwise. So it will be W into 2 equals to R into 4. So what will be the value of R? So it will be W into 2 divided by 4. So when we simplify, R will be equal to W by 2. So means the maximum, like the starting value of the R, when we start this, what will be the value of the R? The value of the R will be equal to half of weight. So example, if we say this is W by 2, this is W. So the starting value will be equal to, the starting value will be for R equals to half of W or half of the weight. That is the starting value. And then when we are moving this book till this position, like if total length is L and we move till this position, then the center of the gravity is here, or the weight of the book this is a position where the weight of the book will act. Like when we move L by 2, because total length of the book is L, as you can see here, the total length of a book is L. So if we move this distance, like the center of the gravity is move L by 2, like the book is now at this position. So book is at this position. We move to a distance L by 2. That's the maximum distance we move. So weight will act downward and normal contact is acting upward. So two forces are acting in the same direction, means same distance. And to create a same turning effect, the clockwise moment must equal to anti-clockwise. So it will be R into, example, if I say this length is 4, so R into 4 is equals to W into 4. Because both have the same length. So it means in that case, if we move to a distance L by 2, or the center of the gravity of the book is exactly lying on this edge, in that case, the normal contact force and weight will be equal to each other. So the maximum value of the normal contact force, or maximum value of the R, will be equal to W. So minimum value is half of W and the maximum value is equal to W. So when we plot a graph, so minimum value is half of W and the maximum value is equals to W when it is moved L by 2. So when we join these points, this will be a graph. Is it clear how we worked out that?
Yes, sir.
So the idea is that the normal contact force is producing an anti-clockwise moment that balance with a clockwise moment due to the weight. And as the normal contact, we are moving the book towards the edge, the normal contact force must increase to create a same turning effect. As its distance is constant, like the normal contact force, this is a point where normal contact force is acting. So that distance remains the same, but the position of the book is changing. So it has to create a greater, like increase the moment. So only thing what happens, R can be changed, but the distance for R is not changing as it is acting on the edge. So question 5B was a doubt, then question 6A. In question 6A, a uniform horizontal flagpole is connected by a hang to a wall at position O. An aluminium wire which connect the pole to the wall at A, as you can see. The free body force diagram for the flagpole is shown. Free body force diagram represent all of the forces which are acting. Identify the forces X, Y, and Z. So, what are the forces X, Y, and Z? First, X, because whenever force is applied by using a wire or a string, that force is called tension. So this one is refers to a tension. Then the downward force, as I mentioned here, this is a downward force. So that is the weight. And what about this Y? Actually, Y is a, as you can see here, this position, it is in contact with the surface. So the surface is also applying a force, and that force is a normal contact force. So Y is a normal contact force, X is a tension as the force is applied by using a string or a wire. So X is representing a tension, Y is representing a normal contact force, and Z is representing the weight. And the last question is 8B, which is a doubt. It's question 7. Question 8B. So in part B, some boats uses a ballast tank, which is refillable tank of water in the base of the boat to improve the stability. So the stability will increase in the ballast tank. Explain why the position X of a ship. Explain why the position of X for a ship when it has a full ballast tank is lower than the ship which is having an empty ballast tank. So what is the reason? Main reason is that like when it is filled with the water, there is a force of the gravity, like its mass will increase, so the gravitational pull will also increase. And the upthrust must balance with the weight. So greater amount of the ship is underwater, so which increase the upthrust because upthrust is equal to density, gravity, and depth. So as a result, it will exert because upthrust as a ship is floating, the upthrust must be equal to weight. Here upthrust also must be equal to weight. So here what happened because as it is filled, so the mass will increase. If the mass will increase, weight will increase. So upthrust must also increase. And how the upthrust can be increased? Upthrust depends on volume of object, gravity, and depth or density of the fluid which it displaces. So the volume of volume of the fluid which it displaces, that should also increase to increase the upthrust because density of the fluid remain constant, gravity is constant. So how the volume of the displaced liquid increases, as like it will displace greater amount of liquid, so the upthrust will increase. Greater upthrust as it has to balance with a greater weight. But here what happens? Because it's empty, as a result, smaller mass or weight, so upthrust will be smaller. And in part B, explain a disadvantage of using a full ballast tank when the boat is moving through water. So when the boat is moving through water, you can clearly see that there is a large area in contact with the water. So if the large area in contact with the water means it will have a greater drag force or greater resistance from the water. So it need more energy or more power to move through the water. Like because there is a large surface area in contact, so it need more energy or more power to move through the water. That's the disadvantage of having a full ballast tank. The boat will be slower. You can mention that. You can mention, but you have to mention a reason as well. Like the boat will, it's of 2 marks, so you have to mention like the boat will be slower. But what is the reason for that? The reason is having mark because the question is explain. In the question they ask the disadvantage. So the boat will move slower, but what is the reason why it will move slower? That will give you the mark. So this was exercise related to the doubts related to exercise moment.